Welcome to the Dynamic Coaching Center. So, what we are going to see is mm, probability. Okay. So, basically, what is probability? Probability is nothing but the chances of getting the desired event or desired value of whatever it is we are going to we need. Okay. So, for an example, here we have a coin. So, if I toss a coin, I might get head or a tail. So the chance of getting answer is 1/2, right? Because it have two possible outcomes, and we might get only one possible outcome, any one of the possible outcomes. But whereas in the die, you'll be getting six sides. So you might get up to six outcomes. So in that six, there is a possibility of getting only one. So the probability of getting an outcome, whatever your desired outcome is going to be 1 out of 6, right? So there are some basics in the probability. So the basics in the probability is nothing but small minor terms, everything. So the one such term is called as sample space. So sample space is nothing. It is the possible outcome of the experiment. So if I'm going to toss a coin, I may get either a head or a tail. So this is a sample space. If I'm going to roll a die, I might get one, two, three, four, or five or six. So this is the sample space. Okay, event is nothing but it's also it is also the subset of the sample space, which comes favorable outcome of which is the favorable outcome of the experiment. Similarly, similar to the sample space, mutually exclusive event is very simple. For example, if I'm tossing a coin, I might get a head or tail. If I'm getting a tail, I will not be getting a head. That is, one event is causing and making sure the other event does not exist or does not occur. That is called as mutually exclusive event. Okay, right. So, so a particular probability can be always written in this formula. That is, a probability of A is going to be the number of probability of cases divided by number of elements in the sample spaces. So for an example, in a coin, you might get any one of the value out of the two possible outcomes. That is why the probability of a coin is going to be 1/2, right? Right. So the total probability is always going to be depending on the number of samples that you have taken, number of events that you are taking into the accounts, right? So one of the most famous theorem in the probability is going to be Bayes theorem. So Bayes theorem basically what it says is, so if A1, A2 till AN are exhaustive and mutually exclusive event, one such event is happening while it is make sure that the other possibilities of the outcome is not coming associated with the random experiment, and B is any event associated with AI. Okay, so the AI is nothing but you'll understand in the example problem. So this is just a formula. So the AI probability of B, it has been associated with AI, right? So again, probability of A1 that will be given in the problem. Probability of A1, B by A1, B by A2, B by A3. Since you know this P of A1, P of B of A1, P of A2 into P of B of A2 is nothing but your total probability, right? So number of occurrence and number of samples is going to be playing a part of role in this. So till end, for example, if we are having six as the number of sample spaces. You should have been doing this problem till A6, right? Okay. B is the event. For an example, out of six, out of six, you want two to be occurring. So B will be this A2 will be two. Okay. And B is the percentage, whatever the question will be asked here. Let me explain you with an example here, right? A factory has two machines, one and two. Machine one and two produces 30% and 70% of the item, respectively. Further, 3% of the item produced by machine one are defective, and 4% of the items produced by the machine two are defective. An item is drawn at random. It is not random, it is random. If the drawn item is defective, find the probability that it was produced by machine two. So first thing you have to understand the question. They're given very simple. They try to explain you, they try to confuse you, but they have given a very simple question. See, you have two machines. Machine one and machine two produces 30% and 70% respectively. Further, 3% of the item produced by machine one not defective. Within the 30%, 3% of the items are defective, and 4% of the items within the 70% are defective in machine two. An item is drawn at random. So they are randomly taking an item from the produced, machine produced items. So if the drawn is defective, find the probability that it is produced by the machine two. So what they are asking is, you're taking a random, you're taking a random item, and they are asking what is the probability whether the taken item is from the machine to production. So basically, this A1 and A2 are machine 1 and machine 2, right? Then this B is the percentage of the amount that we are drawing. So for an example, that's what I told you. The B is the event. So it can be anything. So here they're drawing a defective item. So that B is going to be the defective item. So first thing that we have to do is probability of A1, because according to the Bayes formula, we need probability of you know A1, probability of A2, whatever it is, right? So probability of A1 is 30% of 100 is going to be the machine one produce, that is going to be 0.3, or keep it as 30 by 100 itself. Okay. Then probability of A2 is very simple. It is going to be 70% of 100, and it is going to be 0.7. I keep it as 70 by 100. Then probability of the event occurring from A1, that is from the machine 1, is going to be very simple. It is 3 by 100. That is 0.03. Again, probability of the defective parts taken from the machine 2 is going to be 4 by 100. That is 0.04. Okay. So now we have to find one thing, that is the taken part is from the A2, that is a defective part, that is called as A2 is the defective part, A2 is the machine 2, and the B is the defective part. We have to find this. Okay, so the formula for that according to the Bayes theorem is, this is what the I mentioned in the formula. You understand? This is what the I, because it is associated with the event. Okay, right. So here it is machine 2, since that's why it is 2. So according to that, the formula is going to be always P of A2 into P of B by A2 divided by probability of A1 into P of B by A1 plus probability of A2 into P of B by A2. So this is the formula. So if you are good at the math, you can directly use it as a point or a decimal factor. Or else it is very simple. You can use it as fractional itself. So here we are going to use it as it is given here, right? So here we can directly use this, right? Am I right? So we can directly use this and find the answer. We can use a calculator to find the answer for this. And this is the probability of drawing an object from the defective part. There's a probability of getting an object from the defective part that has been taken there. And that is made by the machine tool. That is 0.75. Okay. So this is the probability of getting the defective part. Right. There's a similar question. If you want, you can try this. I can explain you this question. Assume that the factory has two machines, same type. Machine 1 produces 20 and 80, just the numbers are different here. Here it is 6% and only 1% of the item produced are defective. What is the probability of getting, you know, a random object that has been taken from the production that is made by machine 1? Similar question, similar procedure, but instead of machine 2, they have asked for machine 1. So instead of A2, you have to use A1 here. You get the point? I hope you should have. Right? Right. So there is another type of question that is also given here. Suppose 5 men out of 100 and 25 men out of 10,000 are colorblind. A person is chosen at a random. What is the probability that the person is a male? It is very good. Assume that the male and females are equal in number. So you have to note down this particular sentence. So assuming that the male and the females are equal in numbers. So basically what they are saying is here the probability of A, that is the overall probability, is going to be 1 by 2 because only two possible outcomes are here. One is a male, another one is a female. So there are two possible outcomes. Okay, I mean there are two possible outcomes, and either one of the even can be happen. So either it can be a male or it can be a female. So there's one more point in order to find whether the whether you are doing correct. See, when you add the all the events, it should come as one. So probability of getting a male is P of A, and probability of getting a female, that is A2. Let's assume that this is A1 and this is A2. Is also this is a female and this is for male. So probability of getting male is 1 by 2. Probability of getting female is 1 by 2. If you add, overall probability is going to be 1. Right? That means when you add these two, it should get 1. If it is not getting 1, then you are doing something mistake. So always remember, always the overall probability should be 1, equal to 1, right? Right. So here, 5 men out of 100 and 25 out of 10,000 are colorblind. A person is chosen random. What is the probability that the person is a male? Okay. So again, instead of opening up the answer right now, let's try something. So it is P of A1 is going to be, obviously I have already opened it there. It is 1 by 2 because it is a probability of getting male and it is a probability of getting female, P of A2. Then 5 out of 100, it is nothing but P of B by A1. That is the first event. So P of B by A1 is equal to 5 by 100. Then the second event is P of B by A2 is equal to 25 by, that is 25 people out of 10,000, right? Right. Okay. So apply for the Bayes theorem. Here they are asking for men. Okay, not for the female. So they are asking for men. So apply for the Bayes theorem. A1 by B, that will be P of, this is what you're going to find, P of A1 by B. Okay, instead of I, you have to substitute all the values as A1 and A2, A1. Okay, so substitute the value and find the answer. So this is a very simple problem where uh, we are just learning about the basics of probability. And this is when basics of probability comes into your mind, this is the one of the problem that comes into your mind. So if your guys are doing under Anna University or any affiliated colleges or any autonomous colleges, you may expect at least a 2 mark question from the Bayes theorem, at least a 5 mark question from the Bayes theorem. Okay. Instead of two variables, two events, there may be like three events like this also. So these, but see, n number of variables can come, n number of events can come, but the problem and the formula doesn't change. Instead of A2, you're going to do for A3. Just you will be adding one more event here. That's it. So nothing is going to change here. Okay. You have to try this particular problem. Try this particular problem, and I shall give you something. No. So take this as a kind of homework, and when we come to the next class, we'll be getting into this particular problem. So this is one of the important questions, very few important questions in the first chapter, and this is one of the most important question there available, right? Thank you. Have a nice day.